Okay, pre-calculus. So this is assignment 8. We're going to start chapter 11, so section 11.1 this week. And we'll do 11.2, 3, and 4, all kind of, well, 11.2 with some of 4 in it next week, and 11.3 with some of section 4 in the week after, and then just kind of a little fun thing for the last bit. So we only have 4 more weeks, including this one, of school left. Crazy, right? So let's go ahead and get started. Chapter 11 is about the 3-dimensional coordinate system. So our learning targets are in a 3-dimensional coordinate system, like the one that we live in. So to find the distance between 2 points, to use the idea of midpoint between 2 points, like find the midpoint, or given some other information, use what you know about midpoints. And we're going to talk a little bit about spheres and ellipsoids at the end. So we're dealing with 3 dimensions instead of 2 dimensions. In general, what we have is we've got like x and y, right? So we can have like x and y, and then we throw in z. So here, think of it as like, that's usually what it looks like. Where this xy plane, what we're used to, is like flat. It's like the ground. And then the z is like this, like it goes straight up. So if you look at just like the corner of one of your rooms, right, that's like sectioning off one quadrant of a 3-dimensional coordinate system, where the bottom corner would be the origin, like 0, 0. And then up the wall would be a positive z value. And then either you go this way for x or this way for x, doesn't matter, usually it's this way for x. It's like x would be this direction, and then y would be that direction. And then if you go negative, like you'd go on the other side of the wall, or you go below ground for a negative z. Okay, so ordered triples, this is important. We call them ordered triples, are written x comma, well, I turned my y, or my comma into a y, x comma y comma z. So let me just redo that, x, y, z. So x first, y second, z third, just like the alphabet. We just throw that z on the end. All right, and basically all the stuff we've done with 2 dimensions, we can do again with 3 dimensions, but like instead of like area, we have volume. Now the cool thing is with math, the further you get in it, we don't have to stop at 3 dimensions. We can do 4 dimensions, 5 dimensions. Even though our brain can't really wrap itself around what these graphs would look like outside of 3 dimensions, because right, we live in a 3-dimensional physical world, we can extend these ideas into n-dimensional space, where n is some really, could be possibly some really large whole number. And we can talk about like, hey, what if n is, what happens as n goes to infinity? We can talk about like what stuff breaks down, what works. And we can extend a lot of these ideas to n-dimensional space. Now, when you get into that, a lot of it gets theoretical, or you use a lot of matrices and use a lot of computers to actually run the analytics and do the applications for that. But we're just doing 3 space. So let's talk about distance in 3 space. Remember, distance in 2 space. Sorry, 3 space is 3 dimensions, 2 space is 2 dimensions. So distance in 3 space with 3 dimensions is very similar to the distance formula in 2 dimensions. Basically what it is kind of like, it's the Pythagorean theorem with a little bit added on. So let's say we have 2 points. We got 2 points. We're going to write them as x1, y1, z1 with commas. And then we have, let's use different colors here, x sub 2, y sub 2, z sub 2, right? Those ones should be sub, right? Little subscripts. I want to know the distance between them. The distance d is equal to the square root of the sum of the difference of the squares of all 3 pairs. The big square root. So basically it's, I'm going to try to use the different colors here, x1 minus x sub 2, so that one minus that one, y1 minus y2, and then, oh, there's Emma, z1 minus Z2. Emma, I'm videoing. Thank you. So basically it's just, hey, how far apart are the x's? That distance, and then square it. How far apart are the y's? Find that distance, or displacement, could be negative, square it so it's positive. Find how far apart the z's are, square that, add them all together, make the square root of it. So it's like the Pythagorean theorem, but with that plopped on. Okay, so midpoint, if we have these same 2 points here, the midpoint, which we're going to call M, is just the point directly in the middle. It's midpoint, middle point. It's the middle point, right? You point at your middle. No. So it's the point, three coordinates of, basically, we've got 2 spots. Like, let's say we've got 2 spots here and here. So you can see it better. Here and here. So what it is I've got to go, what's the x difference? Half of that. What's the y difference? Half of that. And then what's the z difference? Half of that. To find the spot in the middle. So we're going to go like, I don't know why I did that facing this way. That was silly. The camera's over here. Basically, I got to find like half the x distance. I got to find the middle of the x's, the middle of the y's, the middle of the z's. The way we do that is by just finding the average, the arithmetic average of each point. So we're just going to go, erase this, x1 plus x2 over 2, add the x's, divide by 2, find the average. That's your new x. y1 plus y2, add the y's, divide by 2. That's your new y. And then z1 plus z2 over 2. Find the average of the z's, right? That's your new z. Cool? Cool. Let's go ahead and do this with an example, like with a couple of points. So let's say we have the points 3, 0, 1, 3, 0, 1, and we have the point 2, negative 6, 3, 2, negative 6, 3. So if I want to find the distance, what I'm going to do is I'm going to say distance equals the square root. I'm going to find the difference between 3 and 2, so the difference between the x's, which is 1, and then square that. Plus the difference between the y's, 0 minus 6, or minus negative 6, is 6. I'm going to square the 6. And then plus the difference between 1 and 3, that's negative 2 if I start here. Because I'm squaring it, I can ignore the negative though, and say 2 squared. So here, it's just 1 plus 36 plus 4, which is the square root of 41. So the distance here, that's our distance. The square root of 41. That's it. Cool. All right, let's find the midpoint of those 2 points. So the midpoint, we're just going to say, well, it's at the point that's halfway between the x's. So 3 plus 2 over 2, well, that's 5 over 2. So that's my x. 5 over 2 for the midpoint. Now we got to find the average of the y's. 0 plus negative 6 over 2. Well, that's negative 6 over 2, which is negative 3. That's the y number for the midpoint. And then here I go 1 plus 3 over 2. That's 4 over 2. That's 2. Or I could have just looked at it and said, hey, what number is halfway between 2 and 3? Well, it's 2.5. 5 over 2. Hey, what number is between directly in the middle of 0 and negative 6? Negative 3, right? What number is it directly in the middle of 1 and 3? Well, it's 2, right? With simple numbers, you can just do that. You don't have to like write this out and say, well, it's in the middle, the midpoint. It's when we're dealing with things that are like crazy fractions or decimals, that sort of thing, that having this formula actually helps us out. Okay, so that's distance and midpoint. Let's move on to talking about spheres. Spheres. Don't say it like that. It's just spheres. Don't say spheres. That's weird. Okay, I mean, you can if you want. I mean, who's listening anyway? We're all stuck at home. Okay. I hope everybody's doing well also. Thanks for watching. Thanks for participating and learning. Okay, let's dry it off. Dry it off. There we go. Okay, so talking about a sphere. So the equation for a sphere, well, let's talk about what a sphere is. A sphere is basically a three-dimensional circle, right? Like think of, well, like a basketball or something of that sort. It's a sphere, right? Where you got a center and every point on the sphere is the radius distance away from that center. So everywhere from that point is equal distant. So for a circle, every point is equal distant. So for a sphere, every point is equal distant, but it's three dimensions. You can also think of taking a circle and rotating it about a diameter. That would make a sphere. So the equation for a sphere, just like the equation for a circle, we gotta throw on that third coordinate part. So here, the standard form equation. Standard form equation, or the standard form sphere equation is, and here we have a center. We're going to put it at x1, y1, z sub 1, and then we're going to have a radius of r. So it's x minus x1 squared plus y minus y1 squared, just like for a circle, but then plus z minus z1 squared equals r squared. You'll notice this looks a lot like the distance formula. If I square root that, right, get square root equals r, that means every x, y, z that makes this equation true is the distance r from the center. That's what makes it a sphere. And then, so that's our equation, where the center's at x sub 1, y sub 1, z sub 1. These are just numbers, and then the radius is r. And the volume of a sphere, v equals 4/3 pi r cubed. R cubed because, well, it's 3 dimensions instead of 2. So we got a couple examples for a sphere, or for problems with a sphere. First, we're asked, like, write the equation if we know what the center is. So here the center is at negative 2, 0, 7. Negative 2, 0, 7. And the radius, r, is equal to 10 centimeters. And then we also want to find the volume. So here, I just go, I've got my x sub 1, y sub 1, z sub 1 for my center. And I've got my radius, so I can just fill it in. So we just go x minus negative 2 is going to be a plus 2 squared, plus y minus 0. Y minus 0 is y. So why do I need a parenthesis there? We don't. So it's plus y squared plus z minus 7 squared equals r squared, which is 100. Fantastic. All right, so that's our equation. Lovely. Now we got to find the volume. The volume is 4/3 pi times the radius 10 to the third. So it's just 4/3 pi times 1,000, which we can just write it as 4,000 over 3 pi. And then the tricky thing here, well, not tricky, but thing to remember is we're talking about centimeters cubed, cubic centimeters. So there's our volume, there's our equation. We're happy. Yeah, cool. We got it. All right. Let's do a more interesting problem. Let's use a different color as well. Here we have an equation, 2x squared plus 2y squared plus 2z squared. That's a 2. Remember to make your z have little arms, right? So it doesn't look like a 2. Like all your z's should have little arms on them, so they don't look like 2, so they don't get distracted or messed up with your work. Minus 2x minus 6y plus 4z minus 6y plus 4z equals, nope, plus 5 equals 0. Plus 5. So what we want to do here, given this, the instructions would be write the equation in standard form so that it looks like this, and then identify the center and the radius, maybe find the volume. You can find the volume from this though, once you have the standard form equation. Okay, on the instructions for your assignment, when you have this, you don't have to find the volume. It'll say on the instructions. So what we want to do here is we identify, like, hey, check it out. 2, 2, 2, 2, 6, 4, 5 rats. Well, remember what this does? Sorry, what we want to do is we want to get all these squares, right? So we're going to have to do some completing the square. What we want to do is we want to make this just x squared, y squared, z squared. And because these, the coefficients on the linear terms, the x, y, and z, the regular ones are all even, we can just divide everything by 2 and deal with the fact that we have 5 over 2 here. That's okay. So, and you could do this by like factoring out the 2 and multiplying it. Let's just divide everything by 2 and make it easier for ourselves. So we're going to divide everything by 2. And I'm going to divide everything by 2 over here. 0 over 2 is just 0 though. So I get x squared plus y squared plus z squared minus x minus 3y plus 2z plus 5 over 2 equals 0. Cool, that's easier to deal with. We do have a 5 over 2, we can handle it though. So now what I'm going to do is I'm going to group and complete the square. So I'm going to say x squared minus x plus blank plus y squared minus 3y plus blank plus z squared plus 2z plus blank equals negative 5 over 2 plus blank plus blank plus blank. I'm going to throw whatever I add in here on the outside. And because we divided everything by 2, right, we don't have to worry about multiplying this or this or this by whatever when we add it the other side, when we add it outside the parentheses. So let's go about like completing these squares, finding a number to go in each blank. So here, take this as a negative 1 divided by 2. That's negative 1/2. Square that. I get 1/4. So here I'm adding a 4th in there. So here, I need to add 1/4 there. Here I take the 3 divided by 2, 3 over 2. Square it. I square the numerator and denominator. 3 times 3 is 9. 2 times 2 is 4. So I add 9 over 4 there. So 9 over 4 adds on the other side as well. And then here I got the 2. Hey, that's nice. 2 divided by 2, right? That's 1. 1 squared is 1. So we just add 1. Wonderful. Yeah. Set that up wonderfully. Now we go out writing out these complete squares. So we're like, all right, well, this is x minus, because it's a minus. And remember, it's half of the b value, the square root of this, or it's just that number that you use to find that. So here it's minus 1/2 squared. So x minus 1/2 squared plus y minus, here we have 3 over 2, right? Negative 3 divided by 2 is 3 over 2. Square root of 9/4 is 3 over 2. So 3 over 2 squared plus y plus 1 squared, right? So that comes from there, equals, and then we got to combine all that. So combining these fractions, 1/4 and 9/4 is 10/4. 10/4 is 5 over 2. So here I have a negative 5 over 2 plus a positive 5 over 2, because negative 1/4, positive 1/4 plus 9 over 4 is 10 over 4. Which is 5 over 2. 5 over 2, that's a 2. Minus 5 over 2 is just 0. So here I just have 1 left over. So, boom, equation. Got it. Yeah. And now I got to say what's the center, what's the radius, and that's it. So here, center for this sphere. Oh, I goofed though. Sorry, please excuse my goof. What should that be? You're right. At least I hope you're right. It should be a z, because it came from the z term. So it should still be a z. My bad. So the center here, opposite of this number, so 1/2 for our x, opposite of that number, 3/2 for our y, opposite of this number, -1 for our z. And then the radius is the square root of this. This is r squared. R squared equals 1. You don't need to do this, but I'm just going to square root it, and you just get 1. So we have a center, 1/2, 3/2, -1 for our sphere, and the sphere has a radius of 1. That's it. Cool. Okay, now we're going to talk about ellipsoids, and that's it for the week. So hopefully this is a little bit more simple than what we had last couple weeks. So I'm going to erase this, and we'll go from there. Hey, so an ellipsoid is like a sphere. Well, you know how an ellipse is like a circle, but squashed a little bit? But it still has like that nice property with like the foci and all that. We're not going to get into all the foci and all the conic stuff and like the parametric equations. We're just going to do the standard form equation, like a little bit of work with it. But an ellipsoid is basically like a 3-dimensional ellipse, where if you cut the cross sections, let me see if I can draw one. It's probably going to be poor, but I'm going to try to draw one. If I have, let's see, it's like this. Ew. Let's make that dashed. Yeah. So, see how I got a better idea. Sorry, I'm going to use 3 colors. Let's draw it here. So I've got kind of like the X there, and then I've got that, and this might not help at all, but, and then I got this. So think of it, this one kind of looks like a football, a little bit, where I have 3 axes. I've got one cutting across the middle, I've got one cutting across top to bottom, and I have one going kind of like where that y-axis goes. So if I were to slice this, each slice would itself be an ellipse, right? As you go away from it, those slices will kind of be weird. Don't worry about that. But it's basically like 3 ellipses, and then everything is curved over to make like a kind of a football shape. Or it doesn't have to be a football. It can look very, very spherical, but just be a little bit off and still be an ellipsoid. Actually, a sphere is an ellipsoid. But these 3 axes act similarly to the way that, similarly to like the radius of a sphere, but right, they're all different from each other. They don't have to all be different. 2 of them could be the same and still be an ellipsoid. Or if all 3 of them are the same, then it's a sphere. But they can all 3 be different and still be an ellipsoid. So we're going to write the standard form equation. So here, the standard form equation is, once again, we've got a center at x1, x sub 1, y sub 1, z sub 1. And then the a, b, and c are is kind of like the radius or half of that axis length. So the standard form equation is x minus x sub 1 squared over a squared, where a in this case would be like this length right here, plus y minus y sub 1 squared over b squared, where b would be this length right here. So like from the center to, in the y direction, to the edge of the ellipse. So like that y-axis area would be, that axis is twice the distance of b, just like with a regular ellipse. And then plus z minus z sub 1 squared over c squared, where c would be this distance right here, and then equals 1. So you'll notice this looks very similar to what we had for just a regular ellipse in 2 dimensions. We just have this 3rd dimension piece added in there. The other thing here that's actually more simple is A, B, and C are just going to sit here. A is going to be under the X, B is going to be under the Y, C is going to be under the Z, and we're not going to worry about necessarily where the foci are, that sort of thing for this right now. We're just going to say A, B, C, X, Y, Z. That's it. Okay, now volume. If I want to find the volume of an ellipsoid, it's just like the volume of a sphere. So it's 4/3 pi, but instead of r cubed, we no longer have a radius that is, well, the same. So it is a times b times c. It's the product of those 3 quasi-radii. They're not radii, but, right, so it's this times this times this times 4/3 pi. All right, so let's go ahead. We're going to do one example of rewriting it in standard form equation, take an equation, rewrite it in standard form, and then find the volume. Right, find the center and then the volume. Okay, so here, and this is the more involved problem. So we've got 25x squared. I'm gonna portion this off here. So 25x squared plus 400y squared plus 16z squared plus 150x plus 32z minus 159 equals 0. I almost said plus, but it's a minus. Okay. So what we're going to do here is we look at it like, hey, it's not like the sphere where something just canceled out, right? We had, if we look at all of these numbers, 25, 400, 16, 150, 32, right? There's not a common factor that we can just divide out everything. So we're going to do some work here. So what we're going to do is we're just going to go about like our completing the square steps. It's just we got 3 things instead of 2 things because we're dealing with 3 dimensions. So I'm going to look at my x's. I got 25x squared plus 150x, okay? And then plus 400y squared. There are no other y's, so I just leave it like that. And then here I have plus 16z squared plus 32z. And I'm going to add this 159 to the other side. So equals 159. Now, I'm going to go about completing the square for each piece, for each x, y, and z. So I'm going to factor out the 25 here. So 25 times x squared plus 6x plus blank. And then plus 400y squared. That's already a perfect square. It's y plus 0 squared, so it's y squared. Now here I go, plus 16 parentheses, z squared plus 2z plus blank equals 159 plus blank plus blank plus blank. We're going to add those 3 pieces in. Right. Oh, not 3, because we didn't have to do anything here. We're just going to add 2 of them, right? Sorry, it's just me going autopilot. Okay. Well, half of this is 3. 3 squared is 9. And then to add to the other side, I got to go 25 times 9, which is 225. Right? Remember that we're adding the same thing. We're adding this 9 25 times, so I got to add 225 to the right side of the equation. The 400y squared is good, just leave it. And then here, right, well, 2 divided by 1 is 1, 1 squared is 1. So I go 16 times 1, which is 16, that I add to the other side. Okay, so now I get 25 times x plus 3 squared, completing the square there, plus 400y squared plus 16 times y plus 1 squared equals, this is all going to add up to 400, right? These still give me 175 and 225 is 400. And we're really close, right? Like, hey, cool, we got like these perfect squares, but it equals 400. We want it to equal 1, and we want some denominators. So we just make those denominators, divide by 400, right? Oh my goodness! I did it again! Dang, rats, look at that. It's y, no, it's not y plus 1 squared. It's z. For some reason, my brain just doesn't want to write those z's. Z plus 1 squared, z plus 1 squared. There we go. So I want to get these denominators, I want that to equal 1. So I'm going to divide everything by 400. Divide by 400, divide by 400, divide by 400. Yes. So 25 over 400 is an over 16 is 1/16. So here I get x plus 3 squared over 16 plus 400 divided by 400 is 1. So I get y squared. We can put an over 1 there if we want. That's fine. And then plus 16 divided by 400, that's 1 over 25. So I get a z plus 1 squared over 25 equals 1 because 400 over 400 equals 1. Hey, that's our, boom, that's our equation. Standard form equation for our ellipsoid. Now, we're going to say, what's the center? Well, the center is going to be the ordered triple of -3 for the x. Opposite of that, here, it's just going to be 0 because there is nothing else with the y. And then -1 for the z. So the opposites, right, just going off of that. And we're going to find the volume. To find the volume, we're going to go 4/3 times pi times a. This is a squared. So 16 is a squared, so a is 4. So times 4, so we're using this, times, well, 1 squared is 1. 1. And then 5 squared, so 5. 5 squared is 25, so 5. So here I get 4 times 5. That gives me 20. 20 times 4 is 80. So I have 80 over 3 pi, whatever units to the third power. Units cubed. That's my volume. And that's it. That's it. So hopefully that all made sense. And hopefully this week's assignment is relatively easy. There are a couple problems with the sphere and with the midpoint that I didn't exactly go over here, but I want you to think about it. Feel free to message each other or email me and ask questions about them for hints. But I think you can handle it. I'm confident you can. So good luck on the assignment this week, and feel free to email me with any questions. Or stop in for office hours, please. Because nobody really does. Okay, I'm going to stop talking.